Okay, we're Team Rocket, and this is our robot presentation. I'm Sophie, Jared, Evan, Mike, and David.
So, the mission for this project was we needed to build a robot that moved while using all 3 motors and all 4 of the sensors.
Originally, like the main goal, we didn't have like a particular like blueprint or something we were following, but we just wanted the robot to be strong, sturdy, and each of the sensors to work. So at first we were working more on having them work independently, and then later we figured out how to like integrate them so it would work more together. Then we wanted it to fit a little bit with our name, and so we wondered if we could make it go, and we said Go Pikachu, or if we could somehow relate it to Pokemon.
Our first problem we had was pretty much attaching the wheels. We had to experiment with a bunch of different substructures. First we tried to put it really spread out with the broke down load, try to make it really streamlined. That ended up being really flimsy. We tried a few more after that. Pretty much we found that if we put the brick on top and make a small substructure with the wheels underneath, that's the sturdiest way.
One other problem that we had during it was that I ended up with the flu, so I missed a couple days during the actual building. But we ended up working it out. They told me to stay home until I was well, and I worked on the journal and the PowerPoint from home. And then Jared kept notes and emailed those to me. Normally I keep the journal, and Kevin took pictures because I usually do that as well. And so then we kept in touch through email and Facebook, and so we were able to keep me informed, and I was still able to participate even though I was home. So yeah, if I lose my voice during the presentation, that's fine.
Yeah, the other problem was the poor robot, Miss Kelsey, and it was heartbroken that she wasn't here. So the second we tried to update the program, we found out our brick was completely dead. Disassembled it, took out the brick, got another replacement brick in it, still didn't work. So not much progress that day. But after that, we got a new brick, it works.
Okay, while our brick was down, we had to pretty much tear the entire robot apart, so we weren't able to work on it. So pretty much while we were bored, we came up with the idea of the grabber claw here. And at first we were just messing around, but then we decided to actually attach it to the robot and help it perform a function. It's just moving back and forth. So we relocated the bump sensor to have it activate the claw and put on some more attachments and gear work just to have the claw work.
Yeah, again, productivity when Kelsey's not around kind of disappears completely. And we're like, okay, we have to stop this robot, cover it with a box. We have to stop. It didn't work out so well, it just kept on going. So instead, we had to hide ourselves in boxes to protect ourselves from our frightening box.
After we build the claw here, we try to connect it to the motor so the motor can translate the motion. So we use the gears to translate that motion, but the problem we have here is we don't have much space between the gears and the claws. So we only use 3 or 4 gears here, and they don't fit perfectly. So our solution is we use the rubber band and tie the whole thing up so it connects all the little space between the gears, and it works now.
The ball holder, we ended up not using it. It wasn't finished yet, but we got finished with the robot. Decided we wanted to try and make a ball holder because the box we have, sometimes when the robot would hit it with the bump sensor, the ball would go flying off it, and of course not pick it up. So use some spare parts and all that to try to make a little ball holder, but ended up having too many problems with it.
So when we reprogrammed it, we decided that at first we would make it listen to sound so it would go. Then we used the touch sensor when it would bump the box, it would stop and then activate the claw. And then after that it would back up. Then we would use the ultrasonic sensor to detect edges to keep it from falling off. but it is still very scary when you see your robot going to the edge and it doesn't stop immediately. Then the light sensor, we decided to put the box over it so it would be dark. It works somewhat. Then the motors would make it move. So this is the screenshots of the program. It's a very long program. At first, the sound sensor is right off the bat. Then it just goes forward. Then the touch sensor activates, which then stops the two motors that drive the wheels. Then after the touch sensor touches something, it activates the claw. Then it backs up and waits till it sees an edge with the ultrasonic, takes up the difference in the distance. Then it goes back forward, uses the touch sensor again, activates the claw again. Then we have it wait for a second because we need to get ready with the box because we're not always ready with it. And then it comes back and we put this over it so it stops. And that's how our program works in a nutshell.
So yeah, we all work with happy and fun time, and we split our works equally between the team members. Each of us gave the idea to improve the robot, and this picture shows at the end of when we finish the robot, everybody's happy.
Anyways, the robot is programmed to, once you start the program, start going at the snap of a finger, go forward, and then when the bump sensor hits the box, the motors will stop, the claw closes, and then it goes and runs back. The ultrasonic sensor then, when it approaches the edge, detects it and stops at the very edge with the wheels half off. And then it goes forward again, bump sensor detects the box, claw opens, the ball usually kind of rolls around a little bit, and then it goes forward. And that's the scary part, is stopping the box in time before the edge. So it's kind of a race against time to stop.
And here is our final robot, the MacGyver box, and we're going to show you how it operates. All right.
Okay.
So let's do it.
Just turn on the light. Okay. On. No, the top one. Yeah.
On. Do we on the program?
Yeah.
Are we sure it's on the program?
There you go.
Okay. Any question? Yep. Thank you.